Hello and welcome to the Unit 4, Section 4 video on graphing and writing polynomials. So in the last section we talked a little bit about the key features of higher order polynomials. In this section you're going to actually be able to take a higher order polynomial, and more specifically the graph of one, and you're going to be able to write the equation for it. So as always, let's recall a few key things that you're going to need, things that you've already learned. Remember, real solutions appear as x-intercepts on the graph of a function. Imaginary solutions do not. We've talked quite a bit about this, that imaginary solutions don't physically cross the x-axis. We talked about the example of a parabola sitting above the x-axis in its entirety, being concave up. So it doesn't cross the x-axis at all. In Algebra 1, you talked about that being no solutions. Earlier in this class, back in Unit 3, we talked about that being two imaginary solutions, okay? Well, now we're going to get into the other aspect of it, which is you have two imaginary solutions, you can have two real solutions, but then you can also have one real solution. Well, where did the other solution go for that when we talked about quadratics? Why do we only have one? Well, in reality, you actually do have two solutions. They just happen to be identical. Okay, so wherever that parabola is touching the x-axis, there's two solutions, but those solutions are the same, so therefore we only write it as one solution. So some solutions can appear more than once, and the fact that we have some solutions appearing more than once, we refer to that as multiplicity. Okay, so for example, if x equals 3 is a solution that occurs twice, we say that x equals 3 with a multiplicity of 2. You can determine the multiplicity of a 0 on a graph by looking at the behavior of that graph at that point on the x-axis. So consider linear, quadratic, and cubic parent functions. So for a linear parent function, we have a straight line, okay? That straight line's got some slope, and because it has some slope, it's going to cross the x-axis somewhere, okay? That line goes right through the x-axis. It doesn't bend, it doesn't do anything, it just goes right through the axis, okay? So the graph has only one x-intercept, and in this case is at x equals 0, and it crosses through that point in a straight line. And this is true of all zeros that occur once with no multiplicity. It just goes through the line. It goes through one end, continues out the other. It doesn't bend, it doesn't curve significantly, where we don't have an inflection point, we don't have a vertex, okay? It just goes through the axis, as simple as that. Well, let's talk about a quadratic function where we have x squared. A quadratic parent function has a degree of 2, which means it must have two zeros. But notice on this graph we only have one x-intercept, and that's at x equals 0. This means that x equals 0 must have a multiplicity of 2. At this point, we actually have two answers. Okay? Think about it this way. If we had x squared equals 0 and we took the square root of each side, we would have x equals 0 as our solution. But what is x squared? X squared is x times x. So if x times x equals 0, either the first x has to be 0 or the second x has to be 0. That's why both of our solutions are 0. All right? So if you have a parabola that touches the x-axis, then you're going to have two solutions there. In a cubic function, we don't have a vertex, but we do have the inflection point, okay, where we go from concave down to concave up. Notice that this graph has only one x-intercept, and that's at x equals 0. This means that we must have a multiplicity of 3 at x equals 0. And the reason we have that is because, think about the equation. X to the third equals 0 is the same as x times x equals 0. Well, each one of those x's has to be 0 for the thing to be 0. So we have x equals 0 as our solution, but it actually occurs 3 times. So also notice that this graph does not cross through x equals 0 in a straight line. Okay? So it crosses with an inflection point. So when you have a cubic going through, you know you have multiplicity of 3. And we're going to use multiplicity to be able to write what our equations are. But before we get into what our equations are, let's talk a little bit about how we would graph this stuff, okay? So let's consider this function. And this is already in factored form for you, okay? Which means you don't have to worry about factoring. We can go ahead and set each part of this equal to 0. Okay? Before we set each part equal to 0, let's do this. Let's do some of the information that we found from the last section. Our leading coefficient. Is our leading coefficient positive or negative? Well, there's no negative sign out in front, so therefore it must be positive. How about our degree? Well, this is all broken up, but we can put our degree together by taking the power here, which is the understood 1, and this 3 on the end. If we add those powers together, since we're multiplying, we get a degree of 6, which is even. So this right here tells us how the ends are going to behave. Remember last section we did end behavior. So we know because the degree is even that it's going to have 2 arrows going up or 2 arrows pointing down on either end of our graph. And because our leading coefficient is positive, we know that those 2 arrows will be pointing up. So it's important to know how the ends behave so we know how to structure the graph. Now let's get some information about the zeros. We can set each part of our factored equation equal to 0, just like we did in the first half of this unit back in section 2. Okay, so if I take the square root of each side, square root of this side is x minus 1, and the square root of 0 is 0, so we get x equals 1. This one's simple. We just subtract 2 from each side. We get x equals negative 2. And for this last one, we have the cube root of each side. Well, the cube root of 0 is 0. And we add 3 to each side. So we get x equals 3. All right, let's talk about the multiplicity. So the multiplicity of this first term is 2 because we have a power of 2. Multiplicity of the middle term is 1 because it had a power of 1. And of the last term, our power was 3, so our multiplicity is 3. Now we're going to use all this information. So we know our leading coefficient is positive and our degree is even, so we know the end behavior. Both arrows on the left and right will be pointing upward. So let's do that on our graph here. So we're going to have 3 points. We've got negative 2 here, we've got 1, and then we've got 3. So let's sketch what this looks like. We know we're coming from the top because of our end behavior, and we're going to come down through 2, and we know that at negative 2, our multiplicity is 1, so we can just keep on going straight on through. And I'm going to redo this just to make it look a little cleaner. Let's try it one more time. There we go. All right, so from here, we look at our x equals 1. Our multiplicity is 2, so we know we're going to have a touching parabola. So it's going to look kind of like that. It's a little off, but you get the idea. And then we're going to have a cubic going through the 3. So I'm going to actually erase the end of this so I can make this a little steeper, because we're going to end up making our cubic like that and going on up. And so this is a rough sketch of what that graph would look like. And you can put that equation that's in the top here, you can put this into Desmos or into your TI-84 Plus and see what that looks like and see if we have the same general shape with this type of behavior at our points. Now here at the bottom of this page, I gave you some steps if you want to more specifically do graphing. It would require making a table and finding out what your y's are for various values of x. You can do that, but we aren't necessarily going to do that here. Okay, we're just doing rough sketches so we get an idea of what the shape looks like. All right, so for the rest of this section, we're just going to go the other direction. We're going to be given a graph, and we're going to figure out what the equation is, or at least what a possible equation is based on the shape of the graph and the behavior of the ends and all that kind of stuff. Okay, so let's just do some examples of these. Let's start off with A. What is the degree of our leading coefficient for A? Well, we know it's going to be odd because it's increasing. And because it's increasing, we know our leading coefficient is going to be positive. Our zeros are located at x equals -1 and 2. So we're going to write our equation. Y equals, you're going to use your x, your zeros, and you know that if that goes in for your x, then we have to get 0 for that particular term, do the opposite of that value for x, okay? So it's going to look like this. We'll have two terms here. We're going to have x plus 1, and we're going to have x minus 2. And then the last thing we're going to do is see what our multiplicity is at our zeros. It's 1 here, so we don't have to write an exponent, but it's 2 here because we have a parabola. So we're going to add a square to that second term. And that's our equation. For B, we have a degree that is even because our arrows are going the same way. And our leading coefficient is positive. Our zeros are x equals 1 and 4. So our equation is going to be x minus 1 times x minus 4. Our multiplicity at 1, because we have a cubic function, is going to be 3. So we got a cube there. And then we don't have to put a power on the other one because it's basically a line. All right, on to the next two examples. So for C, we have a degree that is odd because it's generally moving in one direction. Our arrows are going in opposing directions. Our leading coefficient in this case is going to be negative because we're generally decreasing. Our zeros are located at -7, -3, and 2. And so we're going to start our equation. Now this is important. The leading coefficient is negative, so we got to start with a negative on this one. And then we're going to do what we did before. So we've got x plus 7, x plus 3, and x minus 2. And now we're going to figure out what our powers are. Well, it's 1 for the first one. We've got a cubic going on here for the second one, so we're going to put a cube on that. And then we got a line basically for the last one. So just a cube on that middle one and we're good. For this one, we have a degree that's odd. Our leading coefficient is negative once again. Our zeros are located at -4 and 1. And so we can write our equation. Y equals negative x plus 4, x minus 1, and we've got a square on the x plus 4. All right, for E, our degree here is even. Our leading coefficient is positive. We have zeros at -3, -1, and 1. And our equation is going to be x plus 3, x plus 1, x minus 1, and we've got a square on the negative, or on the plus 1, on the middle term. The degree of this next one is odd. Our leading coefficient is positive. Our zeros are located at -2, 2, and 4. And so our equation is going to be x plus 2, x minus 2, x minus 4. And we have no powers that are needed because this is be multiplicity 1, multiplicity 1, multiplicity 1. All right, so for this next one, we have degree is even. The leading coefficient is negative. We have zeros at x equals -2 and 3. And so for our equation, we have y equals, the leading coefficient is negative, so we got to lead off with the negative, x plus 2, x minus 3, and because we have a parabola touching on both of these are going to be squared. For h, we have a degree that's odd. The leading coefficient is positive. Zeros are located at -4 and 1. So our equation is going to be x plus 4, x minus 1. We've got a cubic at the x plus 4 term, so that's going to be 2 to the third. And then we have a parabola at the x minus 1 term, so that's going to be squared. All right, let's go on to the last page. The degree of this one is even. The leading coefficient is negative. We have zeros located at 0, 2, and 6. So our equation is going to be, leading off with a negative. Now, since we have a 0, we don't need to write x plus 0 or x minus 0. We can just simply write x. And then the next term is going to be x minus 2, and then you have x minus 6. All right, we have a straight line at the x, so no power on that. We have a cubic at the x minus 2 term, and then we have a parabola at the x minus 6 term, so that's a square there. All right, the degree of this one is odd. The leading coefficient is positive. We have zeros at x equals -5, 1, and 4. Our equation is going to be x plus 5, x minus 1, and x minus 4. And let's figure out what the powers are going to be on each of these. We have a parabola here, so that's going to be squared. We've got a straight line here, so we don't have to worry about a power. And then we've got a parabola on the x minus 4. For k, our degree is even. Our leading coefficient is negative. We have zeros at -2, 1, and 3. And our equation is y equals, got a negative at the beginning, that's our leading coefficient. We have x plus 2, x minus 1, x minus 3. And on the x plus 2, we've got a cubic, so it's going to be a third. We're straight at 1, and then we're got a parabola at 3. So we're going to have a square on that last term. And then for this last one, our degree is even. Our leading coefficient is positive. Our zeros are located at x equals -2, -1, 1, and 2. So our equation is going to be y equals x plus 2, x plus 1, x minus 1, x minus 2. And let's figure out our powers. We've got a square, a cube, and then a 1 power. So a square, a cube, and then a 1 power, which we don't have to write on the end. And that's all there is to it. Believe it or not, you can take a graph that looks like that and write an equation of something at least with that shape relatively simply, okay? All right, that does it for this section. That does it for this unit. We'll be moving on in Unit 5 to rational functions and how those work.